Every year, in countries like Brazil, India, and Mexico, hundreds of millions of tons of sugarcane are harvested, giving rise to one of the most consumed and valued products on the planet, sugar. Behind a simple packet you find in any supermarket lies a colossal industry capable of supplying billions of people around the world. But what makes this ingredient, present in something as simple as your morning coffee or a homemade dessert, so special? To find out, we dive into one of the most impressive production chains of the modern world. The journey of sugarcane until it becomes the crystals we all know. Picture a green stalk that thousands of years ago was chewed in Asia for its natural sweetness. That is where the story of sugar begins. In India and Persia, people learned to boil it, to crystallize it, and soon those small sparkling grains became a luxury reserved for kings and nobles in medieval Europe, where they sweetened banquets and were even used as medicine. With the voyages of exploration, sugarcane crossed oceans and found in the Caribbean and Brazil the perfect climate to multiply. But behind its sweetness, there was also a bitter side. Millions of enslaved Africans were forced to work on plantations, making sugar not only a commercial product, but also a driver of both wealth and suffering. By the 18th and 19th centuries, sugar was no longer a privilege, but part of daily life. Beet sugar brought new ways of production, and its consumption soared, shaping diets worldwide. From the simplest desserts to grand celebrations, sugar became inseparable from our history, an ingredient that has sweetened palates but has also left deep marks on humanity. So how is this essential product for humankind actually obtained? It all begins with planting, the first step in turning land into sugar. Cane does not grow from seeds. Instead, cuttings are planted, sections of stalk with nodes from which roots and new shoots will sprout. Farmers select the healthiest stalks, protect them, and place them in deep, well-spaced furrows so that each plant has enough room and nutrients. In just weeks, the land transforms. Green shoots emerge while roots dig deep to keep the plant firm. Drip irrigation delivers water directly to the roots, saving up to half the water and ensuring optimal growth. Pests are controlled early, protecting the roots and guaranteeing that each plant grows strong and uniform. All this care prepares the ground for an abundant harvest, where each hectare can yield up to 100 tons of cane. It is a process where patience, precision, and nature work together to turn simple stalks into sugar. As the cane grows, it enters an intense development phase that can last up to 18 months, depending on the climate and variety. The stalks extend rapidly, reaching 3 to 5 meters, and begin to accumulate sugar through photosynthesis. Sunlight, water, and carbon dioxide are transformed into glucose and fructose, which then becomes sucrose stored in the stalks. A mature plant can contain between 12 and 15% sucrose, while modern varieties can reach up to 18%, combining resistance and productivity thanks to genetic improvement. Farmers' care is constant. Soil sensors monitor moisture and nutrients, while drones apply fertilizers and capture images to detect yellowing leaves or signs of diseases such as orange rust. Pesticides are used only where necessary to protect the environment. Organic cover retains moisture and suppresses weeds, while rotation with legumes naturally enriches the soil. Around 9 months in, the cane enters its ripening phase. Growth slows and sugar content increases. Samples are taken with portable refractometers to ensure sweetness reaches the ideal level, between 18 and 22 bricks. At this stage, irrigation is slightly reduced to stress the plant and concentrate sucrose. With resistant varieties and preventive treatments, diseases like smut are kept under control, ensuring that every stalk grows strong and ready for harvest. Each plant is the result of months of care, technology, and precision, prepared to be turned into sugar. Harvest is a key moment when the cane leaves the field and begins its journey to become sugar. In parts of Asia and Africa, harvesting is still done by hand. Teams of workers use curved machetes to cut the stalks near the base at a 45-degree angle, carefully protecting the roots so the plant can regrow. Each worker can cut up to half a ton per day, removing the upper leaves with precision and stacking the stalks into bundles of 50 to 100 pounds. This method allows them to select only the ripest stalks, though it depends heavily on the weather. Rain can flood the fields and delay everything. In contrast, on industrial plantations in Brazil or Australia, harvest is a spectacle of machinery. Massive harvesters, up to 7 meters wide and weighing 25 tons, advance slowly while rotating blades cut the stalks almost flush with the ground. They strip leaves and residue, chop the stalks into manageable pieces, and deposit them into gigantic containers that are then emptied into waiting trucks. Laser sensors adjust the height to the terrain, and from air-conditioned cabins, operators control everything through touch screens. A single machine can harvest between 100 and 150 tons per hour, replacing dozens of workers and ensuring the cane reaches the mill before losing sugar to fermentation. Even night harvesting has its advantages. Under LED lights, the cane transpires less and preserves more sugars, and nothing is wasted. Leaves and tops cut off remain in the field as mulch, conserving moisture, preventing erosion, and returning nutrients to the soil, though in some cases they are also used for biomass. Coordination is crucial. Harvest must align with the factory's capacity and avoid rains that complicate access. Every delay can mean a loss of up to 1% sugar per day. With planning, technology, and a bit of patience, every harvested stalk becomes one step closer to the sugar that ends up on our tables. Once harvested, the cane must move quickly to the factory to preserve its sweetness and quality. At the edge of the fields, huge trucks wait to receive loads directly from harvesters, synchronized like a perfectly coordinated dance. These trucks can carry between 20 and 40 tons and have reinforced trailers to transport the cane safely. In places like Brazil, fleets of up to 100 trucks follow calculated routes, avoiding traffic and ensuring the cane arrives fresh. In more remote plantations, where roads are less accessible, specialized trains move thousands of tons per day, connecting the fields directly to processing plants. Time is critical. Each hour the cane waits, it loses a little sugar. That is why factories are located near the fields, usually less than 50 kilometers away, limiting transport to just a few hours. On arrival, trucks pass over digital scales that record weight with precision, while automatic probes take samples of the cane to analyze sugar content and levels of impurities, such as soil, fibers, or moisture. These data not only determine how much the farmer is paid, but also adjust the entire process inside the factory to make the most of every stalk. Inside the mill, the cane is unloaded into huge hoppers capable of handling hundreds of tons per hour. Vibrators and conveyor belts distribute the stalks evenly, leading them to the washing area. This step is essential. In tanks with heated water and high-pressure jets, mud, stones, and leaf residues are removed, eliminating up to 5% of the initial weight. Water is filtered and largely recycled, while disinfectants keep the load free of bacteria. In modern plants, even ultrasounds are used to detach particles without damaging the stalks, and rotating brushes ensure every piece arrives clean and ready for processing. After cleaning, the cane moves along enclosed conveyors to protect it from the air and reaches the preparation and crushing stage. First, it is cut into segments of 10 to 15 centimeters, breaking the toughest nodes, and then reduced to smaller pieces of 1 to 3 centimeters. This increases the surface area of the stalks and makes it easier to extract the juice efficiently. The machines, powerful and precise, can process up to 300 tons per hour, and their automatic sharpening systems keep the blades ready to cut with accuracy, ensuring that every stalk delivers all its sugar. After crushing, the small pieces of cane, known as shreds, enter tandem mills, a series of massive rollers working one after another. Each roller can measure up to 2 meters in diameter and weigh 50 tons, applying incredible pressure that squeezes the cane to extract the juice. The cane moves from one mill to the next in a kind of cascade until almost all the sugar is extracted. To recover even more sucrose, hot water is sprayed over the bagasse between mills, a process called imbibition, which helps recover nearly all the remaining sugar. In more advanced factories, mills are combined with counter-current systems, where the juice flows opposite to the bagasse, ensuring nothing goes to waste. The juice obtained is a greenish liquid, slightly cloudy, with an intense sweet flavour, but still filled with fibres and other impurities. It is collected in large tanks and passed through filters that remove the coarser residues. Meanwhile, the remaining bagasse, with about 50% moisture, is not wasted. It is sent to massive boilers where it is burned at high temperatures to generate steam, which drives turbines and produces enough energy for many factories to be self-sufficient, even selling excess power back to the local grid. Next, the raw juice goes through clarification, a process that cleans and purifies it so that the sugar develops a perfect colour and taste. Lime is added to neutralise acidity and help proteins, waxes and salts clump together and settle as heavy flocks. The mixture is slowly heated and gently stirred so the particles bind, and in some factories, special flocculants are used to speed up the process, cutting waiting time from several hours to just half an hour. In more sophisticated processes such as carbonatation, carbon dioxide is injected after the lime to form calcium carbonate, which traps even more impurities and leaves the juice clearer. Once clarified, the juice is separated from the sludge using decanters that spin at high speed, expelling solids by centrifugal force. And in state-of-the-art factories, ultrafiltration filters remove tiny particles invisible to the naked eye, leaving a clean amber juice ready for the next stage, evaporation and crystallization. After clarification, it is time to concentrate the juice into a thick syrup that will become the base of sugar. This happens in evaporators, machines that may look simple but are marvels of engineering. They operate in multiple effects, usually between 4 and 6 units connected in sequence. The juice is heated under vacuum, lowering the boiling point to around 55 to 65 degrees, preventing sugars from burning or caramelizing. The steam generated in the first evaporator is not wasted. Instead, it is used to heat the next, and so on. This saves up to 70 to 80% of energy compared to simple evaporation. Each section works at decreasing pressures, while vacuum pumps keep the system stable. Inside these systems, there is something called a falling film. The juice flows in thin sheets over hot tubes, evaporating water quickly and concentrating the solids from the initial 15% to 60 or 70%. To keep everything running smoothly, the evaporators have automatic cleaners that dissolve mineral deposits, preventing blockages in the tubes. The result is a golden, viscous syrup ready for the next stage, while the evaporated water is recycled for cane washing or imbibition. Then comes the magic of crystallization. Here, the syrup transforms into sugar crystals, and the process is surprisingly delicate. Vacuum pans, either continuous or batch, can handle up to 50 tons of syrup. The temperature drops slowly from 70 to 50 degrees, while variable speed agitators mix the contents. Tiny seed crystals, barely 0.1 millimeters in size, are added to trigger crystal formation, which then grow uniformly until they reach about 0.5 millimeters. Sensors monitor every detail: temperature, concentration, and mixing speed, ensuring the crystals grow perfectly without deformities or false crystals. In more modern plants, even ultrasound is used to accelerate nucleation, cutting batch time from 4 hours to just 2. What comes out after crystallization is called masacuate, a mixture of crystals and molasses. This mixture is taken to continuous centrifuges that spin at 1,000 to 1,200 revolutions per minute, separating the molasses by centrifugal force through perforated screens. To obtain pure white sugar, washes with steam or hot water remove any residue. If brown sugar is desired, a portion of the molasses is retained to preserve its colour and distinctive flavour. Each centrifuge can process between 1 and 2 tons per cycle in just minutes, following precise cycles of acceleration, washing and deceleration to ensure a uniform, high-quality product. With the crystals formed, it is time to dry them and give them the final texture we all recognise. For this, they pass into huge dryers where a constant flow of warm air removes nearly all the moisture without causing the crystals to stick together. At the same time, vibrating tunnels move them gently, making sure every grain comes out completely dry and ready for the next step. Next comes classification. The sugar passes through vibrating screens that separate it by grain size, granulated, perfect for everyday kitchen use, finer sugar, ideal for baking, and even powdered sugar, used across different industries. Each type has its own destination, and everything is done with precision so that nothing goes to waste. In the most advanced refineries, part of the raw sugar is dissolved again in water to create what is called liquor. This liquid is filtered with activated carbon, which removes impurities, odours, and traces of colour, leaving it with near total purity. It is then crystallized once more, producing the refined white sugar we find in supermarkets. Throughout the entire process, quality control teams constantly analyse samples to ensure they meet the highest international standards. Once ready, the sugar moves to automatic packaging. Precise machines weigh and dose each portion, filling everything from small half-kilo bags to large 50-kilo sacks. All packages are sealed airtight to preserve freshness, and the labels carry codes that allow the product to be traced from the field to the supermarket shelf. Even specialised robots stack the boxes onto pallets and wrap them to make transport safer. Finally comes distribution. From warehouses, the sugar leaves in trucks headed to local supermarkets and factories, while large containers cross the seas to reach other countries. All of this is managed by a carefully tuned logistics system that avoids unnecessary stockpiles and ensures sugar arrives on time to bakeries, restaurants, and households around the world. Sugarcane does not only move machinery and mills, it moves entire economies. Countries like Brazil, India, Thailand, Mexico, and Colombia depend heavily on this crop, whether for refined sugar, ethanol production, or even the energy generated from bagasse. The sugar industry supports millions of families, from small farmers tending the furrows to the engineers and technicians supervising the processing plants. Historically, sugarcane has also been a social and political driver. In producing regions, plantation activity has shaped land distribution, labour migration, and the creation of entire communities around sugar mills. Even today, many towns grow around industrial complexes where work in sugarcane may be seasonal but is vital to the local economy. Wages, contracts, and cooperatives directly influence the lives of those who depend on this crop, and the stability of the international sugar market has a direct impact on their well-being. And that is how sugar is made. Tell me, what did you think of the process? I will read you in the comments. If you enjoyed this video, click the like button and don't forget to subscribe to the channel. In the windows you will see next, there are more videos that might catch your attention. Go ahead and watch one. See you next time.